Hi, students. Let's go into Math4 Mathematics Mastery class on congruent triangles. This is Math4 Level 4 Mastery class in Geometry module, the second class. And this class, you need some requirement. One is completion of 2 congruent triangle lecture and their homework assignment in the core. Mastery is much higher than core. In the core level 4 geometry module, that is essential. Or alternatively, equivalent geometry experience. For example, you have solved several logic straightforward geometry problem using congruent criteria. That's okay. Okay? Without one of these 2 foundation, it will be difficult to make meaningful progress in this lecture. So, let's review something. Let's find the starting point of this mastery on congruent triangle class lecture. In the 2 core level congruent triangle lecture, we introduced the main types for discovering congruent triangle in geometry figure, with the goal of transmission key geometric relationships among the angles, segment lengths, etc. Okay. The first type is translation congrution. Congruent triangles, the difference between them is just the location. Okay. The second type is reflection. It can be called asymmetric too. It's a symmetric with an axis. Yeah, this is the axis symmetric. Okay, this is 2. The red line is bisector of these 2 angles. So bisector of an angle is naturally symmetric axis of the angle. Yeah. Here has an axis of symmetry too. The second type is here. The third type is rotation. Rotation congruent have a point, have a center, symmetric center. Around the symmetric center, rotate the figure 180 degrees. It comes back to the original figure. Okay. This is called symmetry triangle. but the responding angle here to here, here to here, responding line here to here has a little different with the axis symmetry. Okay, here to here is more obviously they are corresponding side, corresponding segment. Okay, this angle to this angle, there is corresponding angle. In the rotation type, in the center symmetry, the corresponding relationship has a little different. Of course, the more common in practice is type 4. Okay, is composite type. This one is translation composite rotation. Okay, this is translation composite composite the refraction. Okay, something like that. Only know the type, congruent type is not enough to rigorously prove two triangles are congruent. The key is to identify strict equality among the 6 credential geometry elements. 6. 3, 1 pair, 1 corresponding, 2 corresponding, 3 corresponding, 3 sides and 3 angles. Angle 1, angle 2, angle 3. There are 6 credential geometric elements. Use this theorem can strictly prove two triangles are congruent. Only these 5. SAS, 2 sides and the include angle are equal correspondingly. 2 sides and include angle equal correspondingly. Okay, or a angle side angle side, this angle equals to this angle equals to this angle. 2 angles and include side equal correspondingly. Okay, AAS is a corollary to ASA because of the sum of the angles in any triangle are all the same, 180. You got 2 angles are equal, the third angle must equal 2. Okay, AAS means any 2 angles with one side opposite to one of these 2 angles. AAS. Okay. SSS. 3 sides, all 3 sides are equal correspondingly. Okay? This means, yeah, three sides uniquely determine the shape and size of a triangle. This property called rigidity. Rigidity, sometimes called stability of a triangle. Parallelogram have no this kind of property. Okay? Five side diagram have not this kind of property. Only triangle has it. It's very important. Triangle is rigidity. Triangle is stability. It's very important. The last one happened in right triangle. If two triangle has hypotenuse and one leg are equal, hypotenuse and one leg just need two sides because the angle of right, the angle of 90 is equal. Okay. We are in the mastery level. So our problem solving path has a little difference with the core level. Okay. We began a detective-like puzzle-solving thinking mindset. Okay, what does that mean? Yeah, here is the problem, right down here, the statement right down here. You will get a figure and yeah, the statement need you achieve something, get your conclusion. To reach the required conclusion, you must ask yourself, what the geometric element was I still missing? The conclusion can't be reached. Must something has missing. Where else I can obtain from the diagram? From the basic transformations such as congruent somewhere, or rotation somewhere, some kind, or refraction, okay, or just a translation. Through this kind of geometry transformation, can you get your missing? Okay. This self-question explanation must trace all the way back to the given condition of the problem. When you find a way out, find a way back to the statement of the problem. Yeah, you find the logical chain to solve the problem. Yeah, every link in the reasoning climb must be pushed forward from to given condition to the conclusion inversely. Okay, ensure that every logic step is complete and solid. You find your clue, you find of your missing, this direction to the statement. And you verify from the given to the conclusion, step by step, very clearly, very complete, very solid. Okay. And we also learn specific, powerful techniques on the core level of congruent triangle. Two, not mentioned in these 2 pages. Okay? I must review it in this page. The first one is doubling the median. Doubling the median. A triangle A, B, C. D is the middle point. AD is the median. Double it. Double AD. To E, let ED equals to AD. Yeah. Then you construct a parallelogram. It's a parallelogram of A, B, E, C, Y. Because BD equals BD equals to DC. And you define ED equals to DA. Double the median. So it's very clear diagonal. There's very clear diagram of parallelogram. The two diagonal bisect each other. So there is a lot of clues come out. Okay? This line, this segment equals to this. This segment equals to this. And the opposite side are equals to AB equals to C. The angle relationship is abundant too. Here equals here. Here equals here. Yeah. Here equals here. Here equals here. So a lot of angle or sides can transmit from here to here, from here to here. Any clue happened. It's a very powerful technique. Double the median. Double the median. Double the median. The second one I have mentioned is regard bisector of angle. See it, regard it as axis symmetry. Symmetry axis, okay? That will give you a lot of help. I will show you in the examples. Okay, example. There is a statement about congruent theory. Two triangles, corresponding sides equal. The median to the third side equal. So the two triangles are congruent. Okay. Why this statement can't go into the theorem here? Here 5 theorems. Because the medium is not a side of a triangle. Let us turn this statement to a figure, to a problem, to an example. Yeah, there is a triangle ABC and the triangle A prime, B prime, C prime. This line equals to this line. This line equals to this line. The median on the third side are equal to. Okay. So this is the classical double the median technique used. Okay, why? Because these 3 lines can't construct a triangle. We must find a way, use the equal size to form a triangle. And this is a median. Double median is commanded. It's necessary. 对， is necessary. So, yeah, apply the classical double the median technique. We can prove. How? After double the median, we have learned here. The opposite sides are equal. Yeah, we know AC equals to A prime C prime. After double the median, after the parallelogram formed, AC equals to opposite side, B. Yeah, A prime C prime equals to B prime E prime. Okay. Then AB equals to A prime B prime. That's the given condition. Okay. The last side, AE, we double the median. AE equals to 2AD. AD equals to A prime D prime. Double equals to A prime D prime. So, from the original equation, this equals to this, this equals to this, AD equals to A prime D prime. From the original given condition, we construct SSS. Congruent triangles, ABE. Congruent triangle ABE prime. Then another element jumped out. How to prove the original triangle ABC and ABC prime are congruent? Yeah, we need these 2 sides are equal correspondingly. So we need this angle. equals to this angle. With the include, yeah, include angle. So what I should do is use the previous congruent relationship to reduce, to draw a conclusion on these two angles are equal. How to prove it? From this conclusion relationship, half of the angle BAD is equal, and angle E equals to angle E prime. Yeah, they are parallel line, so this angle equals to this angle. This angle equals to this angle. These two angles combined, the equation still work too. How to write it? Because of these two triangles are congruent, angle BAD equals to angle BAD prime. Angle E equals to, angle E prime. Angle E prime equals to CAD. CAD prime. In the similar reason, angle E equals to CAD. Yeah, the letters are corresponding. Okay, combine them together. Yeah, these two angles, the sum of these two angles, BAC, equals to BAC prime. With the given condition, AB equals to AB prime, AC equals to AC prime. From the SAS theorem. Okay, proved. This is about turn into a statement to a real problem, real figure. Use the double medium technique. Okay, let's go to the example 2. Yeah, beautiful figure. Is a right isosceles triangle. 90 degree, 45, and AC equals to CB. Okay, no need to figure them out so clearly. Okay, just know AC equals to AB. P can be any point. P can be any point on the hypotenuse. Okay, draw perpendicular line. PE perpendicular to AC. PF perpendicular to. After you do some signal on the figure, CEPF is a rectangle, obviously. 4 angles, these 3 angles are 90 degree. So angle EPF are 90 degree are right too. Okay, Then connect EF. Draw the last perpendicular relationship. Now, PG is a height on EF. In the right triangle EPF, in this right triangle, we draw an attitude on the hypotenuse. Now, that is the mean. Okay, then extend this attitude back. That PD equals to CP. Prove two conclusions. These two lines, these two segments in the same length, perpendicular to each other too. Okay. Let's review. Review the types. Obviously, is the reflection. It's very near to the reflection. No? AB near the near the axis, because BC equals to BD. Waiting for proven, but you can assume that they are equal. Okay, CP equals to PD. If we can approve triangle CPB, congruent DPB. If these two triangle are congruent, CB equals to DB. And because this is 45 and then this is 45 too, so CBD is a right angle. The perpendicular relationship be proven too. But what you miss? You only have the common side on these two triangles. You got one side equal correspondingly. You got two sides are equal respondingly. You need the third side. Waiting for proof can't be conditioned. You must find out an equal relationship of three angles, three pair angles. This 45 is very difficult because P is any point, is an arbitrary point on AB. Okay, so this 45 very difficult. Yeah, because P is any point. Angle D equals to angle PCB is difficult too. And these two lines corresponding equal. The first choice is their include angle, these two angles. So we go into the technique we called chasing angle around. transmit the relationship between the angles around the figure. For example, let's find the equal relationship for angle BPD. BPD now is equal to GPA because they are they're on the same two line. What is GPA? GPA, this is 45. EPA is 45 too. Why? Because CEPF is a rectangle. EP parallel to CB, parallel to CF. So it's 45 too. GPA equals to 45 degree. Add G angle GPE. What is the angle of CPB? BPC. Here is 45 too. Why? Because PF parallel to AC2. Here is a rectangle. Minus this small angle CPE. CPE. The remaining step is to prove this angle are equal. This angle and this angle. It's very clear. Why? Chasing the angle around. This angle is complementary to angle E. F is F. Angle GPE is complementary to angle FEP. And this angle, CP, is complementary to this angle because CPF is a right angle. CPE is a complementary angle to FCP. Here is a rectangle. These two angles is equal. We have mentioned it in the common parallelogram. Common parallelogram. These two angles are equal. It's a special parallelogram. So these two angles are equal. They are equal. And FEP angle equals to angle FCP. So these two angles are equal. Chasing the angle around. Okay, so these two angles are equal. Yeah, with the given condition, BP equals to CP. With the common side, BP equals to BP. CP equals to DP, okay? So, this triangle relationship be proved. Then the conclusion be proved. BC, corresponding letter equals to BD. And angle PBD equals to 45.2 because CBP is 45. Then angle CBD equals to 90. The perpendicular relationship be proved true. Okay? So, chasing angle or segment, length of segment around the diagram is very important. It's a logical process. It is also a technique. Question number 3. More and more difficult, a little. Any triangle ABC is any triangle. There are two attitudes. So the perpendicular relationship I drew it out. I figured it out. So AF is perpendicular is a attitude to BC2. But this is not this problem care about. Okay? Okay. Then very strange length equal relationship happened. Extend BD, expand PD, let it equals to AC. BP, this segment equals to AC, this segment. It seems like they have no such important relationship. Accept it. Let it be. Q on EC, a strange equation 2, CQ equals to AB. This long distance segment equal. The problem do it intentionally. Unintent. Okay. Then the length is equal. The relationship is perpendicular. Just like this. The length is equal. The relationship is perpendicular. But they are in different way. Okay. Here. AP is here. Yeah. Let's think about it. Let's find the approach. AP is here. AQ is here. And you got these two lines equal. And these two lines equal. Assume AP equals to AQ happened. AQ, AP. So the approach is to prove AQ. AQ equals to AP. AQ equals to AP. QC equals to AB. AQ QC equals to AB. Yeah, corresponding letter align. Okay, if we can approve AQC, let me find out. AQC congruent to PAB, then the length equation can be proved. What you have missed? What element you haven't? Yeah, there are two lines, two sides, two segments. Yeah. Equal correspondingly. So we need to find the include angle. Yeah, chasing the angle around. Okay, do it again. Do it in this figure. Okay, in the same reason. This point angle is complementary to this angle BAC, and this point angle complementary in the right triangle AEC, complementary to this angle too. Okay, so use the puzzle solving mindset, logic way. Yeah, you got these two angles. You missing the relationship just now, but you find their equation relationship now. So this can be proved. Let us write it now. Angle, this angle ABP is complementary to angle in right triangle ADB. So every given condition will be used. The two attitude used. Okay. 90 minus angle BAD in rectangle, okay, rectangle ADB, this angle Q, I write it QCA equals to, yeah, in right triangle AEC, this angle complementary to EAC. BAD is the angle BAD. Angle BAD is the angle EAC. So these two angles are equal. This very strange relationship. Long distance equal relationship happened. Okay? QC. Yeah. Two sides include the angle. So the corresponding sides are equal. AQ equals AP. the other conclusion, the other mission. Let me improve. This is a right angle. Chasing the angle from. Okay? Yeah. From this concrete, we know, let me try. We know this angle, QAC, angle A equals to angle P. Okay, this angle equals to this angle. And the breakpoint angle combined with angle PAD is right angle. Why? Because here is right angle too. So it's very easy chasing the angle wrong. Okay? Or from, angle CAQ equals to angle CAQ equals to angle BPA. And BPA at PAD equals to 90. So CAQ PAD equals to 92. What that mean? These two angles combined together. PAQ. That is AP, perpendicular to AQ. From this pair of angle equation, we can draw out the conclusion. But how about this? This angle equals to this angle. Can you draw this conclusion out? The Q, so big, equals to A, angle A, so big. From the chasing angle around, we can draw the conclusion too. Let me try it. This Q, what is Q equal? Equal this rectangle at this angle. This is the process. This is the handwriting. You can give your teacher. But we can try another way of chasing angle around in this figure. Okay? Yeah. AQC equals to 90 minus this angle, EAQ. And AQC, from the relationship of concrete, AQC equals to PAB. What PAB equal? PAB equal to PAQ. Add BAQ. BAQ is EAQ. Yeah, these two relationships are equal. Yeah, cancel off. So PAQ equals to 92. That means from any angle condition, draw out this concrete relationship. We all can figure out this angle. All right, perpendicular. Okay. from these two angles equal, it works. From these two angles equals, it works too. The other example, I will give you two solutions. I give you one. You find out another way by yourself. Okay. Question number 4. Example number 4. Yeah. Is ABC is a isosceles right triangle too. Again, okay, happened again. M and N. This figure is a little small. Okay. Yeah. A middle point. The problem double the medium by itself. Okay. M is the middle point. Then double it. Okay, to here. What that means? What that means? The problem double the medium itself. Okay. ADCB is a parallelogram. Okay, is a parallelogram. He do it by himself because he doubled the medium. And this medium double too. Okay, but in the wrong direction. Yeah, if it's double to this direction, for example to O, then OBAC parallelogram too. Okay, but then in another direction. Okay, double. Let me prove ED. Perpendicular to BD. Yeah. So because it is a parallelogram, so AD must connect it. Okay. It's a parallelogram. A lot of angle equation relationship established in the diagram. Angle 2. Here's 2. Can you read it? Read your print file, okay? Angle 2 equals to angle 5. And because M and N in the same place are all the middle points on the leg, on this right triangle's leg. So, yeah. Can you read this kind of axis, symmetry axis? Yeah, just like this. Okay? But in the different direction. Okay? Yeah. Yeah, turn it back. Yeah. 2 slight length. The symmetry axis is here. Just like this. Okay. So you must read a lot of geometry diagram. Okay. To enhance your ability on geometry. Okay. Yeah. Come back to the original position. So MBC congruent to ANC2. So a lot of angle 2 equals to angle 2. T6 equals to angle 6. Angle 6 equals to angle number 3. Yeah. AD parallel to BC. So angle 4 equals to angle 5. Next step is find F. F is the middle point of AD. Why? Because NC is the middle point. No, AB. They're parallel and they're equal. Okay, I take the middle point. A lot of conclusion happened. EAF, ANC, BMC, they are all the same triangle. AEF triangle. Congruent AEF, NAC, right triangle, congruent NAC, MMBC. They're all congruent. A lot of equation transparent, transmit. Okay. Yeah. So here's EFA is 90. What does mean? Middle point and a height and the attitude. Okay, this is attitude. This is the height on AD. Is a medium 2. So triangle AED is isosceles. It's a isosceles. Angle number 4 equals to angle number 5 equals to angle number 2. Okay. Equal number 1. Running handwriting. Easy is 1. Okay. Then let's approve angle number 1 and angle number 2 equals to 90. It's very easy. 1 is here, 2 is here. Any angle, no, because angle number 3 and angle number 4, angle number 3 and angle number 4, they are complementary. Now, the sum of them is 90 because angle number 3 and number 4, their sum was 90. So angle 1 and angle 2, 92. Yeah, that it means these two lines are perpendicular. Proven. Okay, so double the middle, double the medium is very important. A lot of equation happened. Next example is the classical model of rotation, because it happened in a regular triangle ABC, equilateral ABC. Yeah, they give you an internal point A, so this have some degree. Okay, have some degree. Here has some degree. 1, 2, 3. How about here? AOC 1, 2, 4. Minused by 660. Okay. The question is to find out a triangle formed by OAOBOC. Their side lengths are OAOBOC. Where is the triangle? you must draw it out. Just like this. Question number 1. You must organize these 3 lines to form a triangle. Okay, double the median. Translate AC to BE. Yeah, you form the triangle by yourself. You approve this triangle are congruent. Okay, here is the same. But in this problem, rotation. Why? Because 3 lengths are equal. Another scenario to use rotation, hey, is here. Is isosceles right triangle. If we meet an isosceles right triangle, because it is a half of a square. Square have 4 equal sides. Here has 3 equal sides, and the half of the square have 2 equal sides. Meet this kind of scenario, you can think about the rotation. I rotation from one side. I rotation the triangle of AOC. You can rotation any other 2 triangles, AOB or BOC, can reach the same result. Okay, I rotation the triangle AOC. Rotate triangle AOC on the vertex point A. How to rotation? I rotation it clockwise. How? What degree? 60 degree. Rotation elements. Rotation what? About what point? What direction? How many degrees? 4 key elements on a rotation. This is the center. This is the vertical axis of rotation axis. Okay? Crosswise. AOC. So C come to B. C overlap B. C is here. In other words, AC overlap AB. The last one is, where is the original O point? Where it come from? Where it run to? Where is the new place of O? Reading this sentence. AO 60 degree. Clockwise 60 degree. This is 60 degree. So AO, this is O prime. AO prime O is a regular triangle too. So we find after rotation, O's place is here. Yeah, because O prime O is regular or is equilateral triangle. So AO equals to OO slash. Where is OB? Where is OB? OB is OB. Where is OC? Where is OC? C is here. C overlapped B. O Okay, OC equals to O prime B. OB is the OB. So this triangle is what we find. So side length equals to OA, OB, OC is this triangle is triangle O prime B. Then every angle can find out, no? Angle O prime OB equals to 113 minus 60. How about this? Yeah, this is 124. 124. AOC is 124 minus O prime B. O prime B equals to minus, this is 62. The last one. The last one. 180 minus these two. Yeah, sold out. Okay. This is the classical rotation model. Question number 6. Yeah. Isosceles right triangle come back again. And we pick up two equal segments on AB and AE. These two segments we pick up intently. Let them equal. Okay. Then connect B, connect CD. Draw a lot of attitude. Make a lot of perpendicular relationship. Okay. Perpendicular to AF. Yeah. Too well, I don't know. But P. AF is perpendicular to this line, to BE. The intersection point is here. Draw the third perpendicular, 1, 2, 3. Connect on G. Yeah. From the same point, connect. Draw this height, and this height. This height. 3 perpendicular relationship. Yeah. Very strange. Okay. So long BG equals to AF add FG. Originally, two segments add to the third segment ordinarily relate to bisector. In the core class, we have introduced that. But this problem is not. Okay. There are no bisector here. DE, they are the same. They are the same height. They are the same. But which height? It can be any height. Okay. So but separate along the thought of separate long segment into parts. This idea we must learn. Okay, BG. And BG, the part of BG is EG. EG at BE. Sometimes in geometry problem, observation is important. Okay. It looks like a isosceles triangle. It seems like, okay. Can you approve it? Yeah. GEM. GEM is isosceles. If it's isosceles, then yeah, GF cancel off a lot. The only GF is left MF, okay? AF keep it on. Minus FM minus GF. If these two little segments can cancel off, the problem reduced to here. Chasing angle around. Okay, this angle. The base angle. This angle equals to this. This is the complementary to the arc little angle. Okay, these two angles are complementary. How about this? This equals to this. Be careful. The right angle is at is here, not here. Okay. Name it O is MOC. MOC is right angle. OMC is not. Okay. To this. How? Okay. This angle is complementary to this angle. These two angles are equal. Why? Very clear congruent. Yeah. This type is this type again. Okay? No. The axis, the symmetry axis is here. This angle congruent to this angle. I write it down very briefly. Okay. Yeah. Is AB equals to AC. AB equals AE equals to AD. So their include angle is right angle. So triangle BAE congruent to triangle EAD. The problem draw it out. Okay. So the angle, little angle B equals to angle DCA. These two angles are equal. And here is 90 minus this angle, AEB. And this is 90 minus this angle, FMC, minus. Okay. Yeah. Use the equal variables. Use the equal variables to replace this angle. GEM. GME. They have the relationship of equal. So now G base angle E equals to G base angle M. Okay? Oh, yeah. So EG equals to GM be proven. The next one. How to prove B equals to AF? Yeah, add MC. This kind of conclusion happened with the symmetry axis. Okay. If we move the length of MC, MF to the AF, to the P, let MF equals to FP. P on the extension of AF, or P on the ray of AF, and FP, FM equals to FP. FM equals to FP. BC is the symmetry axis. Okay. But how to prove it? In the same mindset, in the same methodology. Okay. Assume these are BC are symmetry axis of these two MFC triangle and the PFC triangle. Here is 45, here is 45 too. Here is 45, here is right triangle. And the angle A is right triangle. So, CP is parallel to AB. It's very clear. So, draw the line by this way. CP parallel to AB. Intersect AF at B, at P. Yeah. Okay. The triangle APC. No? Angle APC. APC, this is right angle. AC equals to AC. These two angle is equal. I introduce and write very briefly because the duration of this lecture is nearly 90 minutes. It's too long. I only introduce till example 6. Okay. So APC congruent. APC congruent BEA. Because I draw the parallel line, the six element, 6 corresponding equation can be found very easily. One, notice here, this angle equals to this angle. Why? Because it's all perpendicular to this angle. Okay? So these two angles are equal, and AC is equals to AB. AS. So AP equals to BE. BE here. Yeah. The last minute, BE equals to AP. The last minute is proof Fp equals to Fm. Yeah, it's very easy. The common line, and they're all 45. Okay, here, yeah, here, they're all 90. Okay, yeah. The last step is MF equals to PF. MF equals to PF. So AP, this is PF. AF 加 PF, AF 加 PF is AP. Then reverse write it. So this is long. Need chase the angle around. Need three pair of congruent with a long logic process. Yeah. Jump out example 7 and example 8. We do summary. Can you read that? Summary. Compared to the core lectures of level 4 geometry, concrete. Yeah, we have long logical processing. More frequency on chasing angle or chasing length. Okay, and more decisive transformation, all kinds of transformation. Rotation, reflection, okay. Yeah, composite of all these kinds of transformation. Yeah, more relationships. Because some example have not running out. 2 example I have no have not introduced. This new technique happened. But more important than this, you need to do homework. You use this technical, use this thought, use this logical process by yourself. So the homework is just below this video. In the board, in the video board. And the answer and hint of the homework of the exercise is in the exercise file. The exercise file have the linkage to the answer. Homework have 14 problems. You need do your best. Use this technique and thinking way to resolve them. Then you become strong. Okay. So yeah, students, see you in the next class, next mastery class. Then we can work together to develop mental thinking, mental competence, particularly in mathematics or in algorithm. Okay, ability. See you next time.